All right, thank you so much. Today we're going to be looking at a topic on trigonometry, and I just wanted to make a summary of the topics, or rather the sections we need to go through in this topic. So the first task will be the conversion of degrees to radians, and vice versa. Conversion of degrees to radians. The second one will be how to compute and analyze, trigonometric ratios and their reciprocals. Then we will look at solutions of right-angled triangles. We will look at angles of elevation and depression. And then we will look at the determination of trigonometric ratios of angles greater than 90 degrees. We'll look at solutions of triangles, and then we will look at the proof of simple trigonometric identities using Pythagoras theorem. And then after that, we'll look at the compound angle formula, and then look at the derivation of the double angle formula. Then we will look at the solutions of simple trigonometric equations of the general form of A sine x b cos x is equal to c. And then we'll finally construct the sine and the cosine waves. I think basically those are the issues that we will look at in this study, in this topic, and I hope you get time to enjoy. So at the introductory remark, I have begun with a unit circle, and I said that a unit circle is a circle whose radius is 1, and then from that radius is equal to 1, you're imagining of a circle that has a radius of 1 unit, so 1 centimeter. Then we want to see the relationship between cosine and sine, and how those values will keep on rotating and changing as we adjust the angles of those values of theta. So take time to go through the video clip, and I hope you will enjoy the lesson. Thank you so much. Now, if the radius is 1, what does that imply? It means that we can use this to see how we can make a reference to the trigonometric functions. Now, allow me to indicate some segments here so that we make this point clear as you saw in the notes I gave. Now, my f would stand for radius. I'll name it just a while. We have another point here, point B. Let me draw a perpendicular line from this point towards the xy axis. So if this is the xy axis, I've said that this is our radius. Our radius is one unit. Is 1 unit. Now you can call it 1 meter, 1 centimeter, 1 inch, 1 kilometer, whatever. It's just 1. So if the radius is 1, then we also saying that the distance from this point A to B is 1, and from A to C is 1, and from A to D is 1, and from A to E is 1, and from A to F is 1. Now, allow me also just to give us the angles of this point so that we're able to see how it changes. So notice, what's the degree? What are you reading there?
44.9.
Thank you, 44.99 degrees. So now that's a unit circle now if this is assuming that this is what we are calling theta, I hope you know what theta is, how it's written. Something close to that. So if this is theta degrees, what is the opposite side? Let me indicate another point here so that you're able to answer. Now, what is the opposite side of that angle theta of 44.99? Yes? What is the opposite side of that angle? Let's move on. Now, we are saying that if you have this angle theta of angle CAJ or CAB, if I was using the outer of circumference, then if you have this angle, this is the opposite side.
Yes.
This is the opposite side of that angle. Of course, we know that this is the height of this triangle. If this is the opposite side, we also know that this is what?
Adjacent.
This is the adjacent side. Utanisamea na hii kalamu yangu haijakuwa sawa sana. And then this side itaitwa
Hypotenuse.
This is the hypotenuse. So that's the hypotenuse side. Now, what we are simply saying about the unit circle is that we know from Pythagoras' theorem that hypotenuse squared is the same as what? Is the same as? Hypotenuse squared is the same as base squared plus height squared. Ukisema ukumbuki. In other words, if we wanted to get any point on this, if we were given this point and this point, we should be able to get the hypotenuse. If we know the hypotenuse and we do not have the adjacent side, we can use this side and this side to get this. And just in case we do not have any of the sides and we have this angle, then we can use that angle to get those sides that we're talking about. So the first thing that I want us to understand is the hypotenuse squared is base squared plus height squared. Now, what is the gradient of, what are the coordinates of point C?
Point C.
Yes.
Coordinates is 0, x 0.
Point C. Point C. Point C. Thank you. Oh, something close to that. Now, let me just, I don't know, I'm looking for my eraser. Okay, I don't know whether to get it here. Now, what I'm trying to imply here is that coordinate is given by the point, the value of x, comma, the value of y, isn't it?
Yeah.
Yes? So now, the value of x is the adjacent side. Yes or no?
The value of x?
The value of x is basically the adjacent side.
Yeah.
Yes?
Yes.
Yes. And the value of y from J to C or to C to J is the opposite side. So the coordinate of y at this point C is the distance from this point to this point, which is reflected upward. More able. So that will give you the value of y. I hope you're getting that. Now, based on that information, now what are we also saying? We are therefore saying that the coordinate of point C, which is xy, is also given by the adjacent side, comma, opposite side. Because the opposite side is the distance from here to here, and the adjacent side is the distance from here to here. So in other words, we are also saying x, comma, y, which is our point C, by the way, take note of that, is also the same as the adjacent side, comma, opposite side. That will be the coordinate at this point C. Yes or no? Umeshikisha? Umeshikisha hapo? Notes zitakuja. Ulikuwa unaandika. Ninasema the value of x, the value of x hapa. The value of x, a value of x hapa, a to j is the adjacent side, which is the value of x. So wacha hata niweka hapa x. Hiyo ni the value of x. The value of y ni the opposite side, the distance from here to here. Sasa hata wacha niweka hapa y. That's the value of y.
Yes.
Na tukasema kwamba hii hypotenuse side ndio the same as radius because it is a unit circle. Tumekubaliana hapo. So in other words, kama nikichora hiyo kitu kama ningali natafuta maeresa kwa hii machine, tumesema kwamba hii ni y, hii ni x na hii ni r, na hii r equals to 1 because ni unit circle. Tumepatana hapo? Now we are applying now the common knowledge that we know about sine, cosine and tangent. Now just a minute, nitafute hii raba yangu, hii sijui raba yangu imepotelea wapi. I don't know whether it is here. I'm looking for my rubber to clean up some of these things. I'll definitely succeed. Raba yangu sijui imeendea wapi. Just a minute, I will sort myself out. Let me just move ahead. Nitapata hiyo raba kito. My rubber on this thing has just disappeared. I don't know where it is gone to, but I'll succeed. Now we also know very well, I think you are also aware that we know from the word that you had from primary, inakuanga nini? Sokatoa. Yeah, that sine is the same as opposite of a hypotenuse. Now, if that's the case, then we are saying that the sine of this angle, hii kitu nisipofuta itatusumbua. Nisipofuta itatusumbua. So anyway, let me just move ahead as I sort out my mess. So we know that sine is the same as opposite of a hypotenuse. Now, hii side hii sine theta, of course we are saying it is sine theta. That is sine theta degrees. Now, this sine, this angle that we are talking about, What is the opposite? Opposite ilikuwa hii distance. Hii distance tulikuwa tunahitaji
y. Opposite.
So we are saying it is opposite. What is the value of hypotenuse?
Value of hypotenuse
1. So we are saying that sine of theta is the same as opposite, because opposite over 1 is opposite, isn't it?
Yes.
Hapo tumekubaliana?
Tumekubaliana.
And this opposite will give you the y value.
Yeah.
It will give you the y value, isn't it?
Yes.
Then we are also saying that the cosine. What is cosine? Cosine is the same as what?
Cosine is the same as adjacent.
This is the same as adjacent. This is our j over hypotenuse, and therefore this is the same as adjacent of hypotenuse. What is our hypotenuse? Is 1. So now by implication we are also saying that cosine of theta is the same as adjacent, and that adjacent is the same as the value of
X.
The same as x. Now with this information, if we go back to our diagram, let me expand this diagram so that we're able to see it properly. If we come back to this diagram, we have said that sine x is the opposite. If you can just remember what we've just been doing, that sine of x is the opposite. The sine of x is the same as the opposite, which is y, and the cosine of theta is adjacent, which is the same as x. So going back to this equation, what we are simply saying is that this x can also be given by the cos of x. So the distance from here to here is the cos of x, and the distance from here to here can also be given as the sine. Not the sine of x, but rather the sine of theta. That the distance from here to here can be expressed as the sine of theta, and the distance from here to here can also be expressed as the cosine of theta. That means that if I wanted to get the coordinate at point C, which was xy, and we said that this xy was the same as the adjacent comma opposite, it can also be written as cos of theta comma sine of theta. Now if I get this point C, the coordinate of point C will be given as the cosine of theta comma the sine of theta, where the theta is the angle that is extending to the outer circle, as you're seeing here. This is our angle. For in our case here, we are saying this is 44.99. So now, based on this information, as we have just put it rightly, that the coordinate of any point along the unit circle, what we are simply saying is that the coordinate of any point along the unit circle will be given by the cosine of the angle that you're talking about and the sine of the angle that you're talking about. So now the value will depend on the value of this theta the value of this theta. And so let me just I hope I'm almost succeeding in getting my rubber. If I got it, I'll be very happy, because I need to clear off these things.
Now he moved his blocks.
That's the rubber I'm looking for. Nataka nitafute rubber. Inakwanga hii kitu inakwanga na rubber hapa, sijui imeenda wapi. Inakwanga tu hapa na sasa hii okay, I've succeeded. This is our original information. Tunataka ikuwe safi. So now, in other words, I will say that this coordinate C is xy. You want the graphics. Oops. The perspectives and graphs. Merudi?
Yeah,
so now what we are saying, that the coordinate at point C was xy, and we have just had a discussion and said that coordinate depends on the adjacent, and that adjacent is given by the cos of theta. And then we have also said it's also given by the sine of theta, because the sine of theta gives you the value from this point to this point. That's what we've just said. And then so now I want you now to look at how this graph, suppose we wanted to extend this. We are moving from point C towards point D. I hope you see.
Yeah.
What happens to the value of x and the angle that we are talking about?
They change.
How is it changing?
When it's moving nearby D,
Yes.
the angle increases.
The angle is increasing.
The value of X reduces.
The value of x reduces. And what about the value of y?
The value of Y increases in a similar way.
The value of y. Now, what will be the maximum value of y?
1.
Exactly. So the value of y will not go beyond 1, because that's what we're talking about. The value of 1, well, the value of y will never exceed 1. So from this, what do we say? Sometimes we normally cram and say when they're asking you about the sign of values. So the sine and the cosine, wacha niingize huyu mtu mwenye amenoku huyu. So the sign of, we mwenye umeingia ukuje na upole. Mute your mic, please. Wait, mute your mic. Silas. Fine. So let's move on. So we were saying that as you adjust this angle from this point, as you're moving towards point D, then the value of x reduces, but the value of y reduces. That is when the angle is between 0 and 90 degrees. Now, I was also saying this, that the value of sine theta here you're saying, because it represents the value of y, the value of sine will never be beyond 1. Because even if you brought this point to whatever point you're moving along, the value of y will never, this is -1, the value of y will never be beyond 1. So that's what the first thing that you need to understand about this unit circle. Number 2, we are also saying that as you reduce the value of x, as you can see, as you increase the angle, let me put it that way, as you increase angle theta, the value of x reduces between 0 and 90 degrees. As you can see, as that angle is increasing to 84 degrees, to 85, whatever it is, the value of x between this point and this point reduces. I hope that you're also noting. Between 90 degrees and 180 degrees, notice this, that as the value of x increases, as the value of x, as the angle increases, the value of x is increasing between 90 and 180 degrees here. And as you move from 180 degrees to 270 here, the value of x is reducing again, just like that. So basically that is what I wanted us to understand and take note of, that the unit circle, the value of theta, the value of x and the value of y will never go beyond 1. The cosine of an angle and the sine of an angle will never go beyond 1. As you can see from all this that we're talking about, whether you're moving out there. From from the notes, from the presentation I did, I also said that the distance between, if you make a 360 degrees turn, then you make what we call a revolution. So from this point, I come back here, I move along until I reach this point. Then this is called 1 revolution. It's called 1 revolution, not radian. That's called one revolution. I think that's what we said. So if I move 360 degrees, I make 1 revolution. Oscar, mute your mic, please. Mute your mic, thanks. So that's how this thing operates. So from 0 degrees all the way to 180 to 270 up to 300 degrees here, then that is what is called 1 revolution. We further said in our notes that this is the first quadrant, and this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant. And we also say that angles are measured from right to left. In other words, angles are measured anti-clockwise. This is just a preview. So angles they are measured anti-clockwise. Oscar, I'm muting your mic and you are unmuting and you are giving us noise. Umetupata darasani bana. Give us our piece. Yeah, just come and relax. Mute your mic because your background has a lot of noise. So in other words, we are saying here that this angle as you're moving. So like this is the second quarter, this is the third quarter, this is the fourth quarter. And we are saying that angles are measured anti-clockwise from right to left. That is 90 degrees. This is 180 degrees. This is 270 degrees, and that is 360 degrees. Now, back to what we were saying. So we had said that sine is cosine, sine theta. We had said that sine theta is the same as the opposite side, which is the same as y over hypotenuse. And we said our hypotenuse is r. That's what we said. Yes or no?
Yes.
We also say that the cos, why is my pen beginning to misbehavior? Imeanza kwenda slow. Let me just something is happening to my machine. Let me. So we have said that cosine, the cosine of theta, is the same as what? Cosine is the same as what?
Cosine is this.
Cosine is the same as adjacent, which is x over r. Now, with that information, we also said that tangent, just a minute here, with that information, I think by now we have all this information at hand. So let me just expand this again so that we're able to see it clearly. We now know also that tangent is given by tan theta is given by opposite over adjacent. But what is opposite?
Y.
And what was y?
Y 0.
No, well, forget about the figures. What is y? How did we get y? Opposite is given by sine theta, which is y, isn't it? And we are also saying that adjacent is given by adjacent is the same as cos of theta. Therefore, tan theta would be the same as
Is the same as y
using sine and cos. Of course, this is y. This is, you have said this is x. So this is the same as sine theta over cos theta. And you have told me very well that this is the same as y over x. Y over x. Now, with that in mind, I also wanted us to understand, therefore, so we know how to get sine, we know how to get cosine, we know how to get that. So in short, we have just said that any point along the unit circle, the value of that, the coordinate of any point along the unit circle, in short we are saying, will be given by the cos of theta comma, the sine of theta. Any point, and I repeat again that any point along the unit circle, the coordinates of those points will be given by the cos of theta and the sine of theta. And we have just seen by this demonstration that as you increase the value of the sine of the cosine of theta, then the coordinates will change respectively depending on the value of that angle. Now, in the earlier notes that I also gave, I wanted us to get to use now the computation using the identities to see how we are able to get the real values of this. Now, let me just, because of time, I will not, because of also I want to save your bundles. Let me assume I have got this kind of a triangle. That is 60 degrees. If this is 60 degrees, 60, what is this triangle called?